In this lecture, we're going to look at the co-yield operator that we can use in our coroutines. As we have seen, this operator is going to pose a coroutine and return a value, and we're going to get behavior we see in code right here. So to make this an actual coroutine, we have to use a coroutine operator. You see, we are using a bunch of co-yields. We have to return an actual coroutine type from this function, or we can use a coroutine type as a return value. And this is going to flag this function as a coroutine in our C++ program. Now we will be using our own coroutine type that we have built on top of the coroutine infrastructure we have in C++20. And this is what we did from the last lecture. And to support the co-yield operator, all we have to do on top of what we had in the last lecture is add a yield value operator. Now, if we call co-yield on something, this is going to be like we are co-awaiting on something we get from calling this yield value here. So if we say co-await in our C++ program, the compiler is going to actually call the yield value method on our promise type, and we are going to co-await on what we get from the yield value method. This is what we are going to do. If you take a closer look, you're going to see that our yield value method is going to return an awaitable. So if we want to suspend, we need to return suspend always. If we don't want to suspend, we need to return suspend never from the yield value method. And once we have this, our code is going to work, and we can use our code to yield values and use them in our C++ program. So our program is going to look something like this. We are going to use our coroutine type looking something like a return value here. And in the body of our function, we're going to use a bunch of co-yield operators. And if we set up a task like we do in the main function here and resume this coroutine, we are going to be running from the starting point where we have froze execution as a result of our initial suspend method that we have looked at in the last lecture. So when we call our coroutine for the first time, it is going to be suspended on call. And if we resume as we do right here, this is going to run up until we hit co-yield 1 here. We are going to get this value stored in our coroutine, and we can access that by going through our coroutine handle, and we are going to see this value printed out. If we resume again, we are going to run up until we hit this line. If we print the value, we should see a 2 printed out here. This is how we can use this thing. If we resume again, we are going to hit the third co-yield point here. And if we print our value, we will see that the value is 3, and our coroutine is going to run to completion. If we try to resume it again, we will be setting ourselves up for disaster, because resuming a coroutine that has already run to completion is really setting yourself up for disaster. You are going to get a crash or undefined behavior. Again, the main point of this lecture is that if you want to support the co-yield operator and use it like this in your coroutines, you need to go in your own coroutine type and make sure that your promise type is implementing the yield value method. And if you have it in place, it is going to work exactly like you want. You see that all we are really doing is setting up another field, which is going to be m value here. And the value we want to yield is going to be stored in this member variable. And we will have access to it through the coroutine handle we have in our coroutine type here. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is co-yield. We are going to reuse the code from the previous lecture, so let's grab everything we need from there. We need the VS Code folder and the main function. The rest we don't need. It is just junk. So we're going to leave that here, and we're going to grab what we need and put that in our current project here. Let's crack this open in Visual Studio Code by dragging and dropping here. This is going to give us our code. We have our coroutine type we used in the last lecture, and it is ready to use. I think we can go in the main function and take out the lines we have to resume, because I want you to see this step by step. And we will take out the coroutine function because we will be using our co-yield operators. And what we want is to implement our yield value method. Let's put that in our promise type. The first thing we want to do is to store the value. This is going to be an integer type. We're going to call this m value as we saw in the slides. And let's take out the return void method here because we haven't really talked about it. This is going to be used to set up the co-return operator, but now we are interested in the co-yield operator. So we are going to set up our yield value method here. You're going to see that it is going to return suspend always to tell our compiler that we want to suspend after we grab the value that we want to yield from this operator here. So we are going to grab the value, we're going to store that in our member variable, and then we're going to return an object of suspend always. This is the syntax we are using here. Once we have this in place, our coroutine type will be ready to use the co-yield operator, and we can go down here and set up our coroutine function. It is a coroutine function because we are using the coroutine operators and we are using co-yield in this case. And we are returning a coroutine type to be able to manipulate this in our main function here. So we are going to set up an object of this guy by calling the doWork method here. And this is going to pose on first call because we are returning suspend always from our initial suspend method here. So if we run our code, we're not going to see anything. Even if we go in and print a message, this message is not going to be seen because the compiler or the computer is going to suspend this coroutine the moment we call it for the first time, as we do here. This is a behavior we have seen from the last lecture. Let's pass the code through the compiler. We are going to use GCC to build this. We already have the F coroutines option from the last lecture, so this is going to compile just fine. If you don't have this in, your code is not going to compile. If you want to put this in from Visual Studio Code, you can come back to your tasks.json file. And if we go to the task to build with our MinGW compiler, we're going to see that we have an F coroutines option here. This is what is picked up by Visual Studio Code and used in our terminal here. I want you to know this. So the build is good. We can bring up a terminal window. Let's close the sidebar. We don't need it again. And we're going to clear. Let's clear properly, and we're going to run Rooster. And our program is going to run. You see that even if we are calling our coroutine here on the first time, the message we have in our coroutine is not going to be visible because it is going to be suspended the moment we call it for the first time. So you can really think that it is going to be suspended at this point here in the body of the function before we do anything. And this is going to be suspending our coroutine. Information about it is going to be stored on the heap as we have seen on many occasions. We are going to store parameters, local variables, and anything we need. And another important thing is going to be the resumption point, and that's going to be the point here past which we are going to resume function execution if somebody happens to resume this coroutine here. Another piece of information that is going to be stored, as we have seen, is the coroutine handle through which we are going to go to resume execution of this coroutine here. Now, this guy has been paused. We can resume it again. And if we do that, we will have access to the value that we have co-yielded here. And this is going to be our 1 here. So we are going to resume our coroutine in our code here. Let's go down and do that. We will do that by calling our coroutine handle directly. If you want, you can even go through the resume method as we have seen in the last lecture. Either is going to work. This is going to resume the coroutine. We're going to see the message here. Then we're going to hit our suspension point, which is going to be this little guy here. We are going to yield the value 1, which is going to be stored in our promise type. When we say co-yield, the compiler is really going to call our yield value method, which is what we have set up on top here. So this method is going to be called up. The value is going to be stored in our promise as we see here. And we will return suspend always to say that we want to suspend execution of the coroutine. But the value here will be stored in the promise type, which is bundled into the information we store in our heap object here, which is going to be really our coroutine state. And it is going to be pointed to by a coroutine handle we can use to resume our coroutine here. So we can go through the coroutine handle and actually access this value. And this is what we are doing here. We are going through our coroutine handle. We are getting its promise type, and then we are calling the m value member variable to print our data here, and we will see the one that we just yielded here. Hopefully this is not confusing. Let's pass this through the compiler. The build is going to be good, so we can clear and run Rooster, and we will see our value 1 printed out here. This is really cool. Our coroutine is working. Let's print a message here and say that we want a new line character to separate these things. We're going to say stdc out stdendl here, and we will resume this again. And if we resume, we will be resuming from the previous suspension point, and that's going to be our point here. So we will resume from line 36. We are going to co-yield 2. Execution is going to freeze, and our coroutine state is going to be stored on the heap. And if we try to go through the coroutine handle to access the data in our promise type, we better see a 2 printed out in our main function here. Let's pass this through the compiler. The build is going to be good, so we can clear and run Rooster. You're going to see that we will see our 2 and we will see our done here, which is going to be the end of our program, and we will see our coroutine handle destroyed because the object using this coroutine handle just went out of scope from the main function here. So this is going to call the destructor of our coroutine type, and we will see our handle destroyed here. This is going to destroy whatever information we might have stored on the heap about our coroutine here, because the coroutine handle pointing to it has been destroyed. This is what we are setting up here. Let's resume again to see the 3 here printed out. So we're going to do that right here. I think we can copy this, print a new line character to separate these little guys. So let's do stdc out stdendl here. And we are going to go down and resume. I think we can do that. Let's make sure we don't have all these things separated by empty spaces. We are going to resume again. So we are going to resume from this suspension point. We will hit the co-yield 3 line here. This is going to yield 3 and suspend execution of this coroutine. So if we go here, we're going to print our 3. And another thing we can do is ask our coroutine if it is done. Let's do stdc out. And we are going to say coro done. And we will say that right here. So we're going to take task. And we're going to grab the handle. And we are going to ask if it is done. So we are going to know if our coroutine is actually done here. And I think we should print stdc out bool alpha to have this information in the form of true or false. So let's do this here, std bool alpha. I think we have access to this little guy here. Let's try and run and see what happens here. So the build is good. We can clear and run Rooster. And we will see that after we print our value 3, our coroutine is not done yet, because we have paused at this point here. So for the coroutine to really end, we need to resume again. And then we're going to hit the end of our coroutine, but we can't grab our yielded value because our coroutine is going to end with an implicit co-return operator, which is going to be right below here. So we're going to be like we are saying co-return. But this operator is not going to work because we don't have a return void method here. So this is probably going to blow up in our face. Let's see what happens. We are going to resume again after the 3 we print here. Let's try to do that. We are going to go down and say task mhandle, and we're going to resume. Let's see what happens. We're going to put a separator here to see this on the terminal. This is a good way to really play with us to understand what is going on behind the scenes. We can pass this through the compiler. The build is good, so let's clear and run Rooster. And we are going to see that now we are going to resume and we are going to hit the end. After we resume, we can ask our coroutine if it is done. I think we can copy this line instead of typing this from scratch. This is going to save us a few seconds. Let's pass this through the compiler. The build is going to be good, so let's clear and run Rooster. And you see that after we do our resume here, our coroutine is going to be done because it will have hit the end. And if you try to resume it again, you're going to be setting up yourself for a disaster because the coroutine has already run to completion. And this is really all I had to share in this lecture, showing you how to use your co-yield operator For this operator to work, you need to implement the yield value method in your coroutine type, or I should say in your promise type. And if you have it set up, everything is going to work as you have seen in this lecture here. Let's test and see if this actually works with the compiler from Microsoft, because it should. And we have a build finished with errors. And you see that the compiler from Microsoft is not going to take this if we don't have a return value method or a return void method. And we're going to see how to set up this method to see proper co-return operator in the next lecture. So go ahead and finish up here and meet me there.